Hey guys, so I'm not here today, so I thought it might be easier if I made a video for your notes. So I want you to copy these all down into your notebook, and then as we go, be writing them down so that you have them to help you with your assignment. So Tuesday, we started section 1 out of chapter 3, and we talked about how to determine if something was a function. So now today we're going to be finishing up section 1 and starting section 2. So we're going to finish section 1. So our first vocabulary word that I want you to make sure you write down is called domain. So our domain of a function are all possible inputs. And what I mean by inputs are our x values. Okay, so we have two options. If you're just given a list of points, like the coordinates 2, 1, 6, 7, 9, 2, then how you're going to write out your domain is you're going to do these little squiggly brackets. They're called French brackets. And you're just going to list all of your x values out. So you'd list your 1, your 5, your 10, whatever your numbers were. If you're given a graph and they're all connected, so it looks something like this, where all of your dots are connected, then what you're going to do is you are going to give me the leftmost number, or your smallest x value that you have on your graph is less than x, which is less than your right number. Now, if your problem or your graph has open or closed circles, that's going to determine whether we have to put the lines here. So if I look up at this one here, this has a closed circle, which means that I should have a line underneath because that's my leftmost point. If I look at this one here, it's a closed circle, so I should have a line underneath because that's the one that's furthest to the right. So if it's a list of points or it's just a bunch of random dots on a graph, you're going to give me your list of points, your list of x values. If they're connected, then you're going to give me your leftmost x value and your rightmost x value. Your inequalities are always going to point to the left. X will be in the middle, and then you have to decide, are you going to have the line underneath, yes or no? So just like domain, we have something called our range. Our range is all possible outputs, which are our y values when we're talking about a function. So same thing, depending on what kind of representation you're given will depend on whether or what your output, your range is going to look like. So if we're given that list of points or a whole bunch of just dots, then you're going to give a list of your y values in your French brackets again. If it's connected, then you're going to give me the lowest y value that you have, y, your highest y value, and just like with our x's, if they are open or closed will depend on whether you have your line underneath your inequality or not. So if I look back up at this one, this is a closed circle. That's my lowest point, so that would go here and I'd have a line. If I look at this one, this is my highest point and it's closed, so I would go ahead and put my line underneath. So domain are our x values and range are our y values. Okay, so what I want you to do is you are going to be finding the domain and the range. So you're going to call this example number 2, and we're going to copy down this graph here. So you're going to call it part A. Okay, once you have the graph copied down with your dots, first thing that I would do is I would go and I would list what each of the coordinates of the dots are. So this one is over 1, 2, 3, and down 2. So that's going to be -3, -2. This dot here is at -1, 0. My third dot is at 1, 2. And my fourth dot is at 1, 2, 3, 1, 2, 3, 4. So 3, 4. Now that I know where my dots are located, their coordinates, now I can go and I can start building my domain and my range. The first thing that I notice is that they are just a whole bunch of dots, which means I'm going to be working with the list of points. So first thing I'm going to do is I'm going to do my domain. So my domain are all of my x values. So I'm looking at each of my dots here, and I am looking at my x value. So my first x value is at -3, so I wrote down -3. Then I have -1, so I wrote -1. I have 1, so I wrote 1, and then I have 3, and I wrote 3 and closed my brackets. For my y value, or my range, I do my y values. My first y value is -2, then I have 0, 2, and 4. So here is the domain and the range for this function. Now, if there's a case where one of your numbers is repeated, so like for instance, we had a dot right here, and so our y value was repeated, we just have to write it down once. So it would still write this as my range, even though I had two dots that had y equals 0 as their coordinates. So my domain might have a different number of terms in there than my range does. And that's okay. Sometimes you have repeats, and you don't have to write the repeats down if you don't want to. Okay. Part B. So go ahead and copy this graph down. We have our x and our y-axis. I labeled each of the points where it kind of switches slopes. So our first point is at -2, -1. Our second point is at 0, 1. Then we have 2, 1, and 3, 2. And then I connected each of my 4 points. Since it's connected, I know I'm going to be working with my inequality, my compound inequalities. So when I want to go and build my domain, I'm going to use this one that says I use the left point and the right point. So first thing I'm going to do is for my domain, I want my left and my right. So if I look at my graph, the point furthest to the left is this -2. So I put -2 is less than. My -2 is a closed circle, so I went ahead and put my line underneath x, which is less than or equal to my right point, which is at 3. It's a closed circle, so I had to put my line underneath. So left and right. For our range, we want our low and our high. So my lowest point is this -1 here. And it is a closed circle, so I have -1 is less than or equal to y. And then I found my highest point. My highest point is right here at my 3, 2. And 2 or 3, 2 is a closed circle, so it's going to be less than or equal to 2. And here's our domain and our range for part B. So remember, if it's a list of points, we just list out all of our x values and all of our y values. If it is if it is connected like part B, then we have to do those inequalities. Main thing to remember on your inequalities is you have to check your dot. Is it open or closed? If this was open on this 3, 2, then I'd have no line under here, and I'd have no line under this one, because it means it's not included. So that is the end of Chapter 3, Section 1. Next, we're going to be moving on to Chapter 3, Section 2. So we're still in chapter 3, section 1. I forgot about this part. So first thing that we have are two more vocabulary words. We have independent variable, which is the input value, the x values, and dependent variable, which is the output or the y values. So input, x values, independent variable, all talk about the same thing. Dependent, output, and y values are all talking about the same exact thing. So you should be able to tell whether something is an independent variable or a dependent variable. So we have the number 3. The function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So you're drinking this bottle of juice, and this equation is going to tell us how much juice we still have in our bottle after we take a drink, or 2 drinks, or 3 drinks, or 4 drinks. Go ahead and write this problem down so that you have it in your notebook, and then we'll talk about what we're going to do with this problem. So part A says that we want to identify the independent and dependent variables. So if we think about independent and dependent, we said that independent variables are our x values, and it tells us that our x values are our gulps. Our dependent variables are our y values, and it says that y is the amount in fluid ounces of juice remaining in the bottle. So our independent are our gulps, and the amount in the bottle is the dependent. Okay, part B. The domain is 0, 1, 2, 3, and 4. What is the range? So the reason that our domain is 0, 1, 2, 3, and 4 is because our x values has to do with our domain, and our domain, or our x values, are our gulps, and you can't take part of a gulp. Okay, so you could take no drinks, you could take 1 drink, you could take 2 drinks, 3 drinks, or 4 drinks. Our goal is to figure out what our range is. So in order to do this, we are going to build a table. So it's going to be 3 columns. We have input on the left, y equals negative 3x plus 12 on the middle, and output on the right. So when I plug in my 0 in for x, I get negative 3 times 0 is 0, and 0 plus 12 gives me my output is 12. So if I don't drink anything in my bottle, I still have 12 ounces of juice in my bottle. Okay, second one, we have input is 1. So I have negative 3 times 1 plus 12. Negative 3 times 1 is negative 3, and negative 3 plus 12 is 9. So if I take 1 gulp of my bottle, I'm going to have 9 ounces left in my bottle. 9 ounces of juice. I'm going to continue this on for 2, 3, and 4. So for number 2, our input is 2. We have negative 3 times 2 plus 12. Negative 3 times 2 is negative 6, and negative 6 plus 12 gives us 6. So 2 gulps of juice is going to give us 6 left in our bottle. For 3, we have negative 3 times 3 plus 12. Negative 3 times 3 is negative 9, and negative 9 plus 12 gives us 3. So if I take 3 gulps of my juice, I'm only going to have 3 ounces left. And for 4, we have negative 3 times 4 is negative 12. Negative 12 plus 12 gives us 0. So if I take 4 gulps of my juice, I'm going to have my juice all gone. So our range are our outputs here. And so our range is going to be 12, 9, 6, 3, and 0. when you put it in this table, it makes it really easy and organized and easy to follow. So that is the end of section 1. So chapter 3, section 1 is now done. So remember, we talked about our domain and range. Domain are our x values. So independent variable, input, x values, and domain all talk about the same information. Our range, dependent variables, outputs, and y values are all talking about the same pieces of information. So that might be something you want to write down here if you have some room, that the domain, the independent variable, input, and x values are the same. And then we have our range, dependent variable, output, and y values are all the same. So that is something I would definitely put in my notebook. Because on your test, I might ask you a question, which one of these are all talking about the same thing? And you would give me the list of domain, independent variable, input, x values are all talking about the same thing. Range, dependent variable, output, and y values are all talking about the same. Okay, so let's move on to chapter 3, section 2. And we're not going to get through all of chapter 3, section 2. We're only going to get to part of it. Okay, so chapter 3, section 2, our essential question is, how can I determine if a function is linear? And that is our essential question. So by the end of this section, you should be able to tell me, how can you tell if a function is going to be linear or not? So a linear equation in 2 variables is anything that can be put in the form of y equals mx plus b. Remember, the word linear means line. So if we graph it, it forms that line shape. Y equals mx plus b. So a linear function is a function whose graph is a non-vertical line. Now remember, vertical goes up and down, and the reason it can't be a vertical line is because it wouldn't pass our vertical line test. For every input, there is exactly one output is the definition of a function, and if it's a vertical line, then for every input there are multiple outputs. So it's a function whose graph is a non-vertical line, so it has to form a line, but it can't be a vertical one going up and down. A non-linear function is a function whose graph is not a line. So just because it doesn't make a line doesn't mean it's not a function, and we saw that in chapter 3, section 1. Okay, so example 1. Are these linear or non-linear? Explain. So I'm going to give you a graph here. So this one is what you call a parabola. So go ahead and label this as 1A. And so it makes kind of this U shape here. It's a U shape. So it is a function because if I take a vertical line and go across it, it's going to only hit one point at a time. So it is a function, but we want to know if it's a linear function or a nonlinear function. It's a nonlinear function because it doesn't form a line. And if it doesn't form a line, then it's nonlinear. Sorry. Okay. B, this one is a linear function because it forms a line. Let's go ahead and copy that one down. So looking at a graph, it should be fairly straightforward to tell if it's going to be a linear function or not. Is it a line? Is it not a line? Okay, but we're not always going to be given a graph. Sometimes we're given a table. So let's look at part C. So in part C, we have x on the top, and we have 3, 6, 9, and 12. And then we have our y is 36, 30, 24, and 18. So first thing that I want to check is I want to check what are my x values changing by. So to get from 3 to 6, I add 3. To get from 6 to 9, add 3. And to get from 9 to 12, add 3. So these are all changing by the same number. For my y's, to get from 36 to 30, we subtract 6. To get from 30 to 24, we subtract 6. And to get from 24 to 18, we subtract 6. So this is going to be linear because as x increases by 3 each time, y is decreasing by 6. So since they're going at the same constant rate on our x's and a constant rate on our y's, that is going to form a line when we go to graph this. So we have one more that we're going to look at and determine if it is linear or nonlinear. So we have part D. X is on the top, so we have 1, 3, 5, and 7. And then we have 2, 9, 20, and 35 for our y values. So for our x values, 1 to 3 is plus 2, 3 to 5 is plus 2, and 5 to 7 is plus 2. So our x values are changing by positive 2 each time. For our y's, 2 to 9 is plus 7. We have 9 to 20 is plus 11, and 20 to 35 is plus 15. So our y values are changing by a different value each time. So this is going to be nonlinear, and our reason is going to be as x increases by 2 each time, the y increases by different amounts. So the graphs should be fairly straightforward to tell if it's linear or nonlinear. And then in our tables, are they changing by a constant number each time? Yes or no? Okay, so example 2, we want to figure out which of the following equations represent linear functions. Explain. So if you say it is a linear function, you need to tell me why you think it is. And if it's not, you need to tell me why can't that be a linear function. So our first one is A. So we have y equals 3.8. Now remember, it's a linear function if you can write it in the form of y equals mx plus b. So I have to ask myself, could I write y equals 3.8 in the form of y equals mx plus b? Yes. So I'm going to say it's linear because I can write it as y equals 0x plus 3.8. If I make my slope 0, 0 times x makes it disappear, which would leave me with y equals 3.8. So this is a linear function. Part B. Y equals, this little box is called the square root of x. Y equals the square root of x. Well, I have to be able to put it in the form of y equals mx plus b. My x does not have a square root in my basic equation, which means this is going to be non-linear because you can't have square roots. No square roots allowed if it is linear. C. Y equals 3 to the power of x. We have to be able to put it in y equals mx plus b. And so if I have y equals mx plus b, my x can't be a power, so this is also going to be non-linear because x can't be an exponent or a power. Power and exponent means the same thing. Okay, D. Y equals 2 over x. I have to be able to put it in y equals mx plus b. Well, x has to be on the top of a fraction for it to be put in y equals mx plus b. Rx is in the denominator, the bottom of the fraction. So this is non-linear because you can't have, or x can't be on the bottom of the fraction in the denominator. There is no way for x to be in the denominator, so this is going to be non-linear. E. We have y equals 6 parentheses x minus 1. So first thing I have to do is I have to simplify this. So I went ahead and I distributed my 6. So I have 6 times x gives me 6x. 6 times negative 1 is negative 6. Now I have to ask myself, is this in the form of y equals mx plus b? Yes. So this is written as, or this is linear because you can write it as y equals 6x minus 6. So we have one more, and our last one that we're going to look at right here is F. We have x squared minus y equals 0. Now we have to be able to put it in y equals mx plus b. In y equals mx plus b, x can't have any powers. So this is going to be non-linear because x can't have an exponent or a power. So you should be able to look at a graph, tell if it's linear or non-linear. You should be able to look at a table, tell if it's linear or non-linear, and then be able to tell if just an equation is going to be linear or non-linear. So in your worksheet today, you are going to be working on domain, range, independent variables, dependent variables, and whether something is linear or non-linear. Good luck. If you have any questions, I will answer them when I come back.